Alright, in this problem we have a ball that we throw straight up in the air. Now when I drew it right here in this diagram, I made it to where it's not straight up, but that was just for the purpose of drawing it. So it's got no x direction, so we're only going to be dealing with the y direction. Alright, so we're looking for the initial velocity. Alright, well, what I did is I made the peak of the balls in the air, the peak, the crest of where it reaches, where its momentum is 0, its velocity is 0. I made that the final velocity, and I made the initial when it was initially thrown. Alright, and we're given that the total time it takes from the initial throw all the way back to the same spot is 2.6 seconds. So I just figured that delta t is going to be 1.3 seconds because it's half of the total time if we're just dealing with the initial and the final velocity. Alright, so our fundamental theorem is going to be the momentum principle, that the change in momentum over the change of time is our force. We also wrote down that the momentum is mass times velocity, and change in momentum is momentum 2 minus momentum 1. Alright, so what we did is separated the velocities from the mass in the momentum formula. Alright, and we know that this is going to be equal to the force times delta t. Alright, because of our formula right here, just multiply force by the delta t gives us our change in momentum, and we know that the force is negative mg. Gravity is going to be pulling down on it. Alright, so the force times delta t is equal to mass. Now we've plugged in 0 for our final velocity because we know that it's 0 at that point. And we simplify our equation to this. The mg instead of the force, masses are going to cancel out. Now we're left with gravity times delta t is our initial velocity in the y direction, and just plug in our numbers and we get our answer, 12.74 meters per second. Alright, now for the second part, we are trying to find the height that it reaches. So we're going to use the work energy principle. Alright, our fundamental principle, the change in energy equals the work. We're going to need the kinetic energy equals 1/2 mv squared. Dot product and change in energy is the kinetic final minus kinetic initial. Alright, so our kinetic final is 0, just as our velocity final was 0. There's no kinetic energy at that point. Our delta E is is going to be negative kinetic energy initial. Alright, and then we set that equal to the dot product. Plug in for kinetic energy, our negative carries over 1/2 mv squared, and then our dot product, and then the force is negative mg still, so the m's cancel out. Whoops. So the m's cancel out, and we're left. Oh goodness. Okay, m's cancel out. We're left with delta ry is equal to the initial velocity squared over 2g. Simply plug in our given values, and we know that the height will equal 8.28 meters. Alright.